everybody. Very happy to be here. I have a long trip from Brazil, and that's quite impressive, the size of this event. I'm quite happy to be here, and good to have some time in the playa as well. And I was expecting to have some time to prepare like a Spanish intro, as I know Portuguese, but it was hard, and I was like, no, the cognitive load will not be able to let me get it. So I'm going to talk about TimescaleDB and how to model time series. So we will start with a small introduction of myself, and also from what's time series data, introduction to also TimescaleDB extension. And then we are going to compare wide versus narrow models for time series, and then we are going to also look for what timescale can offer and how you can tune it for your needs. Well, I am a developer advocate / community manager at Timescale. I live in Brazil. I live in the countryside. I am a permaculture enthusiast. If you don't know what permaculture is, just give it a try. It's a very cool thing to try if you want to farm or have a sustainable life. I worked almost my entire career as a back-end developer. My main language is Ruby, the language that I flow more. And I started with Postgresql in 2004, so that's also part of my career since the beginning. And then a few years ago, I had an invite from Timescale to join the company. I was in the back-end development, and they say, why not become a developer advocate? And I was, why not? So here I am today, very happy with the change. And as a community manager at Timescale, we have a very large community. We have a Slack with like more than 10,000 people. And like 5 to 10 people join every week, so we always have new questions, and people are like, how I design my system, how I do this, or how I do that. And I was like, why not talk about it and explain? And generally, this is more like a mindset talk than like a specific thing. We are going to use one example here, but the main idea is get the mindset, and yeah, that's what we are going to do. So time series data is everywhere. So data is the new gold. It's everywhere, we know, and almost everything is attached to, let's say, a time dimension. So with this time dimension, TimescaleDB started as an IoT company, and they saw like this big opportunity of this big market, and they just see that it was not about IoT, but it's about anything that can be fitting in the time dimension. And you can imagine like any massive data you have, it's probably attached to a time series, right? And we have clients from all kinds of industries like NASA, McLaren, Akamai, and other folks. It's open source, so some of them are not our clients. They just use our technology, and sometimes they interact in our network, so we know they are there, they are using. And it's so cool to see, for example, people from Geneva, also CERN, they start using us and start using more and more. So it's so cool to see people from very different areas, like for example, Warner Bros. Use us to analyze the user behavior on their Warner Bros. Music and things like that. So they are our clients. And we also support several types of things, so it's more like generic enough to allow you. And I'm going to use like a more, like an IoT example here, but we have several challenges in this industry. So generally, when people come to us thinking about how they are going to design, they think like, well, we have this high data throughput, and then like we are going to start this, but if we scale, how we are going to reach that next level, and how we are going to get into that new scale, and so on. And that's a very hard question. So the idea here is compare two different models, wide versus narrow. And we are going to use the example of like, hey, I am at home, I will just build my weather station, and then like I'm just starting small as a startup. Like I'm starting with a weather station, maybe I will scale, expand, and then I will add new features, and how am I going to do that, right? And we are going to start thinking just in this dimensions, like just temperature, humidity, wind, rain, and this type of things. And we are going to skip the location in the beginning just to not be so complex. Just imagine like this is a system that's holding a single IoT device, right? So it's not that bad, it's not that hard. And if you think about like a wide model, what we would have is like all the data in the same table. Simple as that. That's the most primitive thought that you can have, right? So you can just think like you have few columns, and that's how you are going to do that. And if you think about narrow model, so you are thinking more like, hey, I don't need to have like a large table. I can just create a column that label my data, and then I can filter it. So both has their pros and cons, and if you think about the wide pros, it's like much simpler. Like you query and you have everything. Everything is already there. You don't have joins, and you have a very good data compression, because almost all the algorithms that they are compressing data are column-based today. So you just compress it very well. And if you think about the cons, it will be hard to add new things, right? So let's say if you add a new column, or like maybe you have like 1 billion rows already. So how are you going to add a new row there? How you are going to add a new column there? And then as soon as you have more and more columns, maybe that will not fit very well into your model, and so on. And that will become not very efficient, depending on, for example, if your sensors have different time intervals, depending on what type of data you have, right? And the narrow also has a lot of pros that are like, it's very flexible, you can keep adding metrics, you can have like fast writes, because like it's a very small tuples, because like every tuple will just be one sensor, one value, one timestamp, and it seems like a very good, efficient data storage, right? But if you try to start building more things over, if your system is full of features and things, maybe you have more work in the other side, right? So you have less computational power, but more mindful decisions, right? So that's the trade-off of this decision. And the compression will not be that good, because if you are having like a column named value, and this value is like once it's 1 and then it's 100,005, it will not be very easy to find an algorithm that can compress numbers that don't have a good pattern, right? So generally compression works well when you have like a map of types and things that you can reuse. So Timescale has like 8 different types of algorithms to compress. So depending on the type of your data, it will try different algorithms and different heuristics to compress the data. So it will change. So let's do like a knowledge test here. Like I'd like to check if you are understanding what I'm saying here. So I don't know if you can open your arms or not, because maybe you hit your neighbor, but your colleague. But the idea is like, if we are going to have a narrow model, maybe you do like this, or maybe you do like this, and then if you have a wide model, just do a sign with your hands. And let's do the first test. So if I need to design a system, an IoT system with a fixed set of sensors and dense data collection, what would you use? Okay, so the public is divided here, right? And this is wide, right? So who answered wide here is the right answer, because if you say that they are your fixed set of sensors, so you are not going to change. So a single table will work well, right? And what if you have like a monitoring system that you start collecting metrics? So metrics are very flexible, and maybe they will be different. So what would you use? Narrow. Very good. Thank you very much for who tried to answer. Yeah. Well, this is the basic thing that you need to think when you are starting, right? So a lot of people, they come with this question like, I don't know what I'm going to store, or I know exactly what is the type of data. And then it will also depend on like the time interval. So maybe you are collecting temperature every hour, and then let's say humidity every minute. So maybe wide will not be good, because you're just repeating data and so on. So that's the main idea, right? And then if you think like the data flexibility in the wide model, it's limited, right? So you don't have like that flexibility. You need to find new ways, and maybe it will be just better for querying, right? And for querying complex system, it will be hard, right? And for writes, maybe that will be the inverse, right? So if you are writing a very large table, maybe you spend too much time on writing, and maybe not all the values are there, right? So if you maybe you are not like filling the values with the same patterns and so on. And for the efficiency of the storage, you see that it's very inefficient using a wide model if you have like sparse data. If you are not like going to have the same patterns, maybe that's not the best model for you, right? And the compression will work quite well if you have like a very dense data on the wide model, and not that well for dense data in the other side. So this is all about pros and cons. It's not like a receipt that you can just say like, well, use this or use that. So it will depend, and maybe you will evolve to different things, right? Later I will share more about like you have also the medium, like not wide, not narrow, but the medium term. So you can also build it, and then depending on the stage of your business, you transit from one to the other, right? And that's funny. I just put some code here to show that like implementing this is funny. Like if you look at the code difference, like the wide model versus the narrow model, like I just have like one or two lines differing. Like I'm not going to have the attributes column, and then I will have one metric type instead. So, and if you're going to insert the data, that's also not that different, right? So you have like insert, and then maybe when you are going to insert one metric, you will put all the values together. But when you are in the narrow, you need to have three. So depending on how you are going to store it and how you are going to send it, you will have like several transactions, or you have a single transaction. Are you going to work with batches, or are you going to collect the data, have a middle stage which you can store and flush the data at some point and stream everything? And for querying, things will start getting very different, because when you are querying data in the wide model, it's just like select star from, right? So you just need to do the select star from, and then when you query the narrow model, then you need to start like, well, I can just query, I need to build a query for every type of model I have, and then I will need to have this, and then like, it's not about like filtering the metric type, but behind the scenes, the query plan will be very different. So if you think like in how the database search and do how the database do the data trip to get the data into the storage and serialize it and deserialize, and how it's searched for the tuples, how you are going to need extra indices to also make it happen in the narrow model versus in the wide model. So things will be very different. It will like depend. For example, maybe it's better to have even a table for each sensor, right? So I could have like a table for temperature, another for humidity. So it will depend on your business model. So in the beginning, the code differences are really small, right? So you don't have too much to do. You don't have too much work. You don't have too much effort, like to design a narrow versus wide. Like this is just a few lines of code. And both models look simple, right? But you have an impact on the system architecture that will be your long-term issues and headaches or blesses that you feel like, oh, I'm feeling good because I chose that model. Now it's more flexible or less flexible. And in the narrow model, probably you need to design extra components and layers to just start building. Maybe these layers will be directly like views in the database. Maybe you prefer to have everything in your code as a way to control. And as you evolve your system into more complex scenarios, you see how you are going to adapt your code. And the main answer that we see in all kinds of questions here is like, it depends, right? So we will have a very different thing. So and in the maintenance, for example, in the wide model, for example, you think like, imagine you have like a table that's already running. For example, we have clients. They are running like, oh, we are ingesting like 1 billion metrics per day. So, and if you think like 1 billion metrics per day, you can imagine that they have a few terabytes of data already or petabytes of data. So it's not that easy to update it, right? So it's not like, oh yeah, let me do outer table, add column. No, it's not that like that. You will not be able to do it. This is like several days or months until you get there, because you need to have like a rollout strategy, a way that things will go. And in the other side, like if you have a narrow model, oh no, let me just add a new metric. It's just a different value. Maybe I will add a new index to just cover that new value or do some specific thing there. But it's different. And even in the narrow model, depending on how big is your table, for example, how much storage you need for adding indexes and so on, right? And if you think about the scale of this thing, like wide model will be very much less suitable for this like multi-metric thing, and depending on your target, like, oh no, I'm looking for better data compression. I'm just using this system to store the data. This is more like an auditing system, or like, no, this is like a real-time dashboard thing. So how much I will need to work to get there or here, right? So it will vary a lot, and the faster option will be always like, oh no, narrow model looks much faster in terms of like ingesting things, and querying wide model will be much faster. And I'm not sure how familiar you are with like the internals of Postgres, but like Postgres has like a pagination system, and depending on the data types that you are using, like the pages, they have like a static let's say a static size. So And for example, if you have different types, for example, if you are storing logs, they have like a text, and text can vary. So Postgres, for example, adopts a thing named the toast. So toast will create a table object storage. So if you have like a big text that will not fit on that page, it will just place that thing in another table. And then like you think, oh no, I have this narrow table, I can put everything there, but maybe it's not there, it's in another table. So you need to go through these internals to get some of this. So it depends on the type of data. For example, if you are talking about floats here, that's not the case, right? But it will all impact. And more you know how the system works in the back end, slow you take the decisions, I would say, right? And so now I would like to do some exercising, right? So generally, like this is how the system evolves. So let's say we are going to add a new feature here, right? So how would this small weather station support multiple devices? So I have a small farm. I started with my single device, but now I'm just having more devices and more locations. So generally, in the wide model or in the narrow model, I would do the same. For example, if I need to support more devices, or maybe I would define like, oh no, let's move now. I will rename this table that I have as my garden. Let's say that's the name of the weather station. I have it my garden, and now I will have one in the other field. So I will call it house A or house B. So you can store a narrow model into one table per device, or you can store it like adding a new column, adding a foreign key. So, and for example, adding a foreign key will have a cost, right? So every time you are going to insert something, it will just start checking the other table if the data is there and if you are doing something very consistent. Generally, we say like in the Postgres ecosystem, if you can, like especially with time series, if you can denormalize things and just break some rules, like don't use the foreign keys if you can, like, and sometimes it will be much easier, like, oh no, I will keep this data forever here. I'm going to audit this and keep or things like that. So it will just impact your ingest rates a lot. And depending on the level of consistency that you need or you don't need, you can give up on some of these features. So denormalizing data sometimes is very important. And for example, if I'm going to add a new feature, like that's a new column in the wide model. Seems easy if you are starting. Not that easy if your system is already running for quite some time. The narrow model, I just add a new row. I will just have one more line in starting metric. I will have one more transaction, and I will make my server busy in I/O and CPU and somehow. So you need to measure it. And querying a single metric is just like querying one column in the wide model. But if you have an error, you need probably to have an index by this metric type to allow you to speed up the velocity of your query. And if you have multiple metrics, you will carry multiple columns and so on. And then let's say you identify that your device has some broken sensors, and then you have to have a new version of your device. So how are you going to put this new version of your device? Are you going to track it using a device table? Are you going to have like a version inside this narrow table or the wide table? How are you going to split this? So every small feature will have a great impact in the architecture because you have an extra cost for new features, right? And if you are going to scale devices, well, my system is going well. I found an investor. He wants to put like 100,000 devices now in his big farm. How are you going to do that? Will your system support it? So if you, depending on your ingest rate, you think like, oh, if I go to the biggest machine I can get on EC2 whatever system maybe that will even not be enough for the throughput that you are expecting. So how are you going to shard or partition or whatever you choose for your way, right? And you have impact. You have like huge indices, more storage, you have like huge backups, and maybe you add replicas or you add more reliability and things that will make things much harder. So all these things can be part of your mental model if you think like how system can scale in narrow versus wide model, right? This is the type of questions that I always answer on the tech design channel. So if you want to join the Timescale community, this is a link that will let you there. And I hope you enjoy and also learn, because I learn a lot from other people that are developing things and other guys that have real systems running. As a community manager, I am there and I am always just helping, but several times I'm just learning from other folks that are in the community and they have like real cases. I remember some days ago, some months ago, we have a guy from NASA that was like, oh, we have one problem here. We have like 500,000 floats that we are going to just read them 50 times per second. And this is just one unity, and we want to scale it to 120 unities, and we want to know if Timescale will hold such workload, right? And this is funny to see, like very complex cases and what people adopt and how people think when they are building such things. So Timescale is, our internal motto is like hearts and brains. So we always talk that like decisions in IT are also emotional, right? They are not only related to our brain, but we also have a connection with the tools that we use. And we believe that a lot of people are already using Postgres. Like if you think about like how long have you been using Postgres and the workload, and then you think about extra languages. Like I am here in Spain, I talk Portuguese, and I can listen almost everything in Spanish, and I feel like, oh, I am understanding things without knowing this. And when you go to a new technology, it's exactly like this. You can just go and read it, and then like, oh, I understand give it a try. Try to write it. Try to speak Spanish if you don't speak. So it's not that easy. So the Timescale bet is like we are going to offer technology for who is already using Postgres, right? Because that's the point. You already have your data there, and it's just like making it on superpowers. So I will be talking about TimescaleDB. That is our extension. Timescale is the company. And Timescale, we have our own product that is a Timescale Cloud. And we use TimescaleDB as a door for people to know what we are doing, but this is just an extension. Our cloud is much smarter than the extension. We have much other features that are not available in open source. And the cool thing is like it's only an extension. So it's your Postgres. You don't need to install like a forked version of Postgres or anything. And we have people on the petabyte scale. So that's the cool thing. And the key thing is the query performance that we do a lot of parallel scans, reads and writes. So through partition by time, we can do such things. And with compression, we have people reporting 95, 98% of storage savings using the compression system. So we have a compression policy that you can just say, well, if the data is 1 week old, you just compress the data, and it automatically gets compressed. And the compression system is very interesting because you are compressing the entire table. So you are not compressing like a row or a batch of rows. So when you do data time partition, you are saying like, well, I would like to have one table per month or per year or per day. So for example, we have clients that are very huge. They have like 1 table per hour. So it depends on this. And then when you are compressing, it's just like copying the entire table to a compressed table, and then it swaps the table reference. So and then when you, for example, if you have like, we have also retention policies. So if you are going to do to hold something for like just a week, you can also drop this entire chunk and partition, and it's just like truncating the table. So internally on Postgres, what happens is that you have a lot of metadata to allow you to just like get a good query plan. So the Postgres stores details about your data and choose the fastest data trip to find. And then when you truncate it, you just drop this, so you don't have that to worry about that vacuum. So if you delete row by row, you have this type of problem. So that's how it shines. And the hypertable is the main concept. So hypertable is the table that we call as an abstract table. So when you use the hypertable, you have this automatic partition by time. It supports multiple dimensions. So for example, let's say you want to isolate your customer, you can add an extra dimension that will also be, let's say, oh, I would like to have one partition per client per month. So if you drop the client, you can truncate the entire partition, and that will be really fast. Then you go row by row, especially in case of millions or billions of rows, and so on. And then the data retention and compression policies are very, very interesting, because you just say, well, every 2 hours or every day, just run this thing, compress the data, or delete old data, and that can be very useful to create like data pipelines and data workflows. And what it would look like if we do this. So I'll be just like generating this very fast here. So we have the weather data wide here, and I create a new database here. So if I just join here and say create extension TimescaleDB toolkit, I will add here toolkit because I'm going to show you something. Toolkit, an extra extension for improving the way you do queries and data science stuff. And I just created the 2 extensions. So the create table is exactly the same, but we have this create hypertable function call. And that's how it would look like, right? And you can put extra params like this chunk time interval. So by default, it's 1 week of data per table. You can say a month or a day and so on. And there are several other configurations, like if you want to have extra partition modes and so on. And the narrow model, it's also very similar. So I'm just typing here, copying to not spend too much time. And this is an insert with random data, just to show you some real things. So we are just getting like random temperatures from 10 to 20 degrees, and then humidity as a percentage, and wind, and so on. So in this case, we are getting like 1 month of data every 1 second. And then in generating random data. So, oh, sorry, I would like to just enable timing here, so you can see how much time it will spend to generate this data. And it's around 2.5 million rows that it's going to insert. And it's like 8 seconds to insert 2.5 million rows. So in my MacBook M1, not that bad. And then if you see here, \d and weather data wide, wide narrow is empty, wide is here, and you can see here number of child tables. So in this case is a week table, so I have 5 child tables, and then it will automatically choose the right thing from the right table if you use a where clause saying, well, just data from yesterday. It will not go to the 5 tables. It will just go for the table that contains your data, and that's what makes it very fast. And when you need to go to multiple tables, it can parallelize and divide and conquer. So that's the key thing here. as I have just 5 minutes, I will just skip some of the other inserts here, and just show some other stuff. So if I'm going to query things, like that would be very easy. For example, query less data here, and but one thing that everybody needs is to be aggregating data. So for aggregating data, we have a concept that we call CAGs. And that's like the official name. That nobody calls it continuous aggregates because it's too long name. But basically, what you can do with continuous aggregates is create a materialized view that is also hyper table. It's also partitioning your data and everything, but it's flowing to another table, and then you can also use like a real-time option or not. So for example, in this case, if I create this, for example, I'm just it's already creating with all the data, so in 1 second it was able to process all the records, and then what you can do here is that if I just say \d+ here, weather data, wide data, daily summary, you'll see here the entire definition of this table. It's interesting because it contains like your select clause from what you are doing, but it also contains, oops, for some reason I got it duplicated, so let me just do it again. Yeah, and so it's getting from the hyper table, but it's also getting data from real time. So it knows what data is materialized and what's not materialized, and then when you query data, by default, it joins the data from 2 data sources, so it's very useful for dashboarding, and you can also disable it. It's just a configuration. Right. And from the toolkit thing, what I want to share with you is the idea of having like hierarchical things, because when you are aggregating data, generally what you have, in this case, you see that I'm using something named statsEggs, that is this special function here. And statsEggs is like an intermediate state of data. So if I say here table, weather data, wide, hourly summary, limit 1, you see here that it's not like the real data. It has this crazy metadata. And what you can do is that you can extract several metrics from this metadata. So it's already processed, and then I can say, now, for example, I can say count, I can say average. So for example, if I say here, select average, aggregate temperature from, it will extract this information from this metadata. And the cool part is that I created it hourly, but now I would like to create it daily. So instead of reprocessing the raw data, I can use this roll up function. So roll up function will merge metadata with metadata, and then you can also use it in this sense of don't need to reprocess anything, right? So you can reuse, and then if I just, for example, I just get average here, and then, for example, now I can say daily, for example, daily summary. Oops. Yeah, I renamed the column. But yeah, that's the idea. You would get exactly the same result. And yeah, here is an example getting from the data. And you'll see, like, I can get the average, I can get the number of values that are inside, the standard deviation, and several other types of statistics. So that's how Timescale help in this area of like digesting time series and dashboarding and doing this type of aggregation of data. You can also add like policies and say like, well, refresh this, I don't want real-time things, refresh it every hour, refresh it every day, and then you can also create different policies. And the compression is very good because when you compress the data, you can also order your data, you can segment your data, and what to do, it's like if you, for example, let's say you have a device, then you you are going to have an array of values from the same device, and then it will just turn like several rows into a single row of array of values, and that will compress much better than the normal thing. And I would really encourage you to give a try on compression and see how crazy it is. Here it will not compress that well because I'm just using random values. It's like it will not like have very good deltas between the values. Like you have very random values, and you can also compress your data manually. You can decompress it, and we also support like inserts in data compressed and delete compressed data and so on. So we are implementing all these things now. And we also have extra dimensions. And for example, in this case, I am just adding here, and I am saying, don't try it in production. We still say that it's experimental. We need to have more feedback. So if you try it and if it works for you, give a feedback for us. It's very important. Maybe we can elect it as a production-ready feature, and that's a very important also for us to have this feedback. And yeah, so now I have some extra tests here, and well, as the time is getting over, I will not have too much time for it, but that's like almost everything that I have. Just remember to ask yourself what type of thing you are building, and don't try to build something that's not exactly what you need. And think about these details, like what's your system topology, where the data is coming from, how I'm going to digest this data. I'm going to have intermediate servers and things like that in the middle. Yeah. If you are interested in having an extra middle term metadata, this is a very nice blog post about this intermediate state of data, and having metadata like controlling like when data is up to date, when data is not up to date, and this type of things. It's also a very good recommendation. So I have some extra resources. Later I will be sharing this the link of this Markdown gist with you, and you can see it. So I don't know if you have time for questions. Yeah, thank you very much.